That pilot study was just looking into the effects on sand. Now, the main study that they're hoping to do will actually take a look at the soil that is around wildfires all throughout our region.
Millions of bees poured into Nevada's desert, or so the story went. Clips and comments mocked what people called bee dumping, branding it cruel, costly, and destined to fail. But a month later, those same voices were whispering something else. What if the joke was on them?
Some people call it dirt. It's a very, very complicated thing from a chemistry perspective. So we wanted to start rather simple. But was surprising to see that also the coal smoke itself turns the soil what we call hydrophobic.
The story gripped social media because it sounded both reckless and bold. Why would anyone try something so wild in the middle of a desert? And could there have been a hidden logic behind it? This video dives into the soil struggles, the secret power of desert bees, and how a mocked idea turned into a story that made critics regret every word. Desert problem. Viral rumor. It began as a strange rumor on local news sites and grainy social media clips. The claim was simple, almost ridiculous. Trucks in Nevada were supposedly dumping millions of bees straight onto desert ground that looked more like a salted wasteland than farmland. The images spread fast, workers in protective suits unloading buzzing containers while white crust glistened across the soil. To outsiders, it looked insane. Comment sections filled with laughter, environmental groups cried foul, and even seasoned agricultural experts scoffed at the very idea. A death sentence for bees, some headlines warned. Others called it nothing more than a publicity stunt that would collapse within weeks. Yet the story wouldn't die. The more people mocked it, the more attention it drew. Because beneath the laughter was a darker question that many weren't willing to say out loud. Why would anyone even try such a thing in the first place? Nevada, after all, had long been seen as a graveyard for crops. The desert state had always fought with its soil, its heat, and its unpredictable water. Farmers there were desperate for solutions, and desperation can make bold ideas look deceptively reasonable. That backdrop is what made the rumor so sticky. Nevada's soils carry the scars of ancient lakes, leaving behind layers of salt and minerals that poison ordinary crops. Yields had been shrinking for years. Farmers were spending fortunes trying to fix land that seemed determined to fail them. Anyone who knew agriculture understood that the battle wasn't just with heat or water, it was with the very chemistry of the ground itself. And so, when whispers of a radical bee experiment surfaced, it felt oddly plausible. Maybe crazy, but also maybe possible. The timing couldn't have been more perfect for the story to explode. Across the country, saving the bees was already a rallying cry. News outlets ran features about collapsing honeybee populations, lawmakers drafted pollinator protection bills, and backyard gardeners proudly planted wildflowers for bees. People were primed to care and primed to argue. So when the supposed bee-dumping story hit Nevada, it struck two nerves at once: outrage over animal welfare and curiosity about agricultural innovation. Could bees really survive in salty soil? Was this reckless cruelty? Or was there some strange genius hiding under the surface? The mix was irresistible. On one side, critics mocked Nevada as the punchline of American farming. On the other, a growing chorus of voices asked what outsiders might be missing. Why Nevada? Why bees? Why salt? Even those who laughed hardest had to admit, there must have been a reason someone tried it. And this is where the story shifts from rumor to revelation. Because few people realized that Nevada's salt-crusted ground wasn't necessarily a barren death trap. In fact, those alkaline soils, the very feature that looked so hostile, might have been the perfect invitation for a particular kind of pollinator. One that didn't fear the desert, one that had been there long before tractors, irrigation pipes, or headlines ever existed. Few realized that Nevada's salty soil might not be a death sentence at all. It could be exactly what some bees were waiting for. Soil that fights back. Nevada has always been a gambler's state, but for farmers, the gamble often comes with no payoff. The challenge isn't just the searing heat or the relentless droughts, it's the soil itself. Long before highways and casinos, this desert land was covered by massive prehistoric lakes. As they dried up thousands of years ago, they left behind heavy deposits of salts and minerals. What looks like ordinary farmland on the surface can be hiding layers of chemical traps underneath. Roots burn, yields collapse, and farmers spend fortune after fortune fighting a losing battle. This is the alkaline problem. Salt accumulates in the upper layers of soil, locking up nutrients that plants need and creating conditions that only the hardiest weeds can tolerate. In Nevada, many farmers tried flushing their fields with water to wash salts deeper underground. But with water so scarce and expensive, it was like throwing cash down a dry well. Others experimented with soil additives, hoping to rebalance the chemistry, only to discover the salts resurfaced within seasons. Over time, families watched their fields produce less and less. For many, agriculture wasn't just hard, it was nearly impossible. Yet there was one plant that seemed to defy the odds: alfalfa. With its purple blossoms and deep root system, alfalfa could tap into underground water reserves that other crops couldn't reach. For decades, Nevada farmers leaned heavily on it, especially as alfalfa hay became a valuable commodity for livestock feed across the West. But here's the catch: alfalfa's true gold mine isn't just in hay, it's in seeds. High-quality alfalfa seeds command serious prices on the market, and producing them can turn struggling fields into lucrative enterprises. The problem? Alfalfa doesn't give up its seeds easily. Each flower has a peculiar spring-loaded mechanism. To release pollen, something has to press just right on the petals, triggering them like a tiny catapult. Honeybees, the go-to pollinators for most crops, aren't built for the job. Many avoid the snap entirely, finding it too aggressive, while others trigger it clumsily, reducing the chances of successful pollination. The result? Beautiful purple fields that looked healthy but produced almost no seed. Farmers were bleeding profits because the plants simply wouldn't reproduce. That's where the rumor about dumping bees into salty desert soil began to make sense. Desperation breeds experimentation. If alfalfa needed a special kind of pollinator, one tough enough for the flower's snap and rugged enough for Nevada's alkaline earth, then maybe, just maybe, the strangest idea could also be the smartest. And when whispers spread that Nevada farmers had found a way to make that happen, people couldn't stop talking. The internet loved the story for a different reason: the imagery. The contrast was stark, almost cinematic. On one side, lifeless white salt plains that seemed hostile to anything living. On the other, swarms of buzzing bees, the very symbol of life, nature, and renewal, being poured into that wasteland. To critics, it looked like a farce. To supporters, it looked like rebellion against the impossible. Either way, it was absurd enough to go viral. But what the headlines missed was the deeper truth. Nevada's salt-crusted soil wasn't the enemy for every species. In fact, for a very particular kind of pollinator, it was the perfect invitation. While honeybees struggled, other bees, natives shaped by desert time itself, saw the salty ground as the ideal foundation for their survival. Because the truth is, not all bees are created equal, and some desert natives see salty soil as home. The bee that fits the lock. The story of Nevada's bee dumping might sound like pure internet folklore, but science gives it an unexpected layer of credibility. Out in the deserts of the American Southwest, researchers have discovered something remarkable. Deserts, often dismissed as barren wastelands, are actually some of the most bee-diverse ecosystems in North America. Against all odds, places with scorching heat and scarce rainfall are home to an astonishing variety of pollinators, each finely tuned to survive where others fail. Some of these desert specialists are more than survivors, they're specialists. Take the squash bee, for example. While honeybees may flit between many flowers, squash bees devote themselves almost entirely to squash blossoms. They rise early in the morning, often before the sun clears the horizon, and complete their pollination before the day's brutal heat sets in. Or consider the Mojave poppy bee, a tiny insect with an almost science fiction survival tactic. When drought years stretch on, these bees can go into a suspended state underground, waiting until rainfall finally revives their world. Then, in sudden abundance, they reappear to pollinate desert blooms that had been dormant alongside them. These aren't just bees. They're living examples of desert adaptation. That's why the Nevada rumor struck a chord. It wasn't just the spectacle of bees poured onto salt flats. It was the possibility that farmers had tapped into an overlooked truth. Certain crops, like alfalfa, require pollinators with very specific strengths. The flower's spring-loaded petals are more than a quirk. They're a barrier that generalists struggle with. Honeybees, celebrated as the world's great pollinators, tend to avoid them altogether or trigger them inefficiently. For farmers depending on seeds, that meant acres of purple fields blooming beautifully but failing to produce. But what if Nevada farmers had turned to a different kind of bee? A bee evolved not in lush meadows, but in harsh alkaline soils, one that didn't shy away from the flower's mechanics, but embraced them. Imagine a pollinator that found Nevada's salty ground not hostile, but welcoming. A bee that, rather than building hives in trees or man-made boxes, carved its home directly into the earth. Each female digging her own chamber underground, protected by the very salts that seemed to repel all other life. Suddenly, the rumor didn't seem quite so far-fetched. This is where the science of ground-nesting bees becomes key. Unlike honeybees, which need hives and beekeepers, many desert natives live solitary lives. Each female digs her own tunnel, builds brood cells, and stocks them with pollen for her young. For these bees, the soil isn't an obstacle, it's a home. And they don't just tolerate certain soil types, they require them. Moisture levels, salt content, and soil structure determine whether a nesting site succeeds or fails. For Nevada, that meant the very alkaline conditions that destroy crops could create a fortress for bees uniquely adapted to it. So when videos claimed farmers were pouring bees into salty plots, the idea resonated. Yes, it looked absurd. Yes, critics laughed. But beneath the mockery was the knowledge that desert bees do exist, and they do thrive in places most insects would avoid. Creating a bee bed out of salty soil wasn't just random madness. It lined up with decades of entomological research on how ground-nesting pollinators behave. The rumor worked because it wasn't entirely out of thin air. It sat on the edge of possibility. Which leaves the real question. If Nevada's farmers had indeed gambled on desert bees, what came next? Because the test of any pollinator isn't how they look when released. It's what happens when the flowers bloom and the harvest begins. If that was the case, then the real test wasn't the release. It was what happened in the fields weeks later. performance people didn't see coming. When the rumor of Nevada's bee experiment first broke, the focus was on the surface spectacle. Trucks, salt, and swarms of insects scattered across pale ground. The critics assumed the story ended there, with bees either dying or flying away. But weeks later, whispers suggested something different, something that forced even the most skeptical observers to take a second look. The bees hadn't vanished. They were working, and they were working harder than anyone had imagined. One of the first signs was timing. Farmers began noticing pollination activity stretching far beyond the usual windows. Honeybees, reliable in mild conditions, typically retreat during the punishing heat of Nevada afternoons, but these desert-adapted bees seemed to ignore the sun's intensity. They were out at dawn, stayed active through midday scorch, and continued late into the evening. Each extra hour meant thousands more flower visits, which, multiplied across entire fields, added up to staggering gains. Farmers spoke of blossoms alive with movement long after other pollinators had disappeared for the day. The rumor suddenly had teeth. Something unusual was happening out there in the heat. Then came the efficiency numbers. Alfalfa is notoriously difficult to pollinate, its spring-loaded petals acting like tiny traps. Honeybees often avoid them, or they get slapped by the flower and move on, failing to transfer pollen effectively. But the supposed desert bees? They handled the flowers like professionals. Landing with precision, they triggered the mechanism every time, covering themselves in pollen and moving it seamlessly from bloom to bloom. Observers claimed nearly every flower they visited ended up pollinated. Success rates so high that they defied the averages taught in university classrooms. Instead of fields with scattered seed pods, acres of plants were swelling with promise. To those watching closely, it felt less like chance and more like design, as if these bees had been built for the job. But the real story wasn't just what happened above ground. The surface images, mocked online as foolish or cruel, missed the most important detail. Beneath the salt-crusted soil, the bees had built something astonishing. Each female carved her own tunnel, creating perfectly rounded shafts that branched into chambers. There, pollen stores and eggs formed the next generation, shielded by soil chemistry that deterred parasites and pathogens. The salt, once ridiculed as a poison, turned out to be a protector, holding moisture in place and keeping the underground environment stable. What from the outside looked like barren wasteland was, in truth, becoming a subterranean city, alive, growing, and self-sustaining. That hidden world explained the sudden transformation in the fields. It wasn't magic. It wasn't luck. It was the quiet, invisible labor of millions of insects, perfectly matched to their environment. The viral videos may have sparked laughter, but those who walked the fields weeks later weren't laughing anymore. They were counting pods, measuring yields, and realizing something profound. The bees were outperforming every expectation. It was at this point that the narrative began to shift. What had started as a joke was becoming a case study in possibility. If Nevada had cracked the code, if this strange method worked, then the agricultural playbook was about to be rewritten. But with success came attention, and with attention came imitation. Not everyone, however, understood the hidden sophistication beneath the surface. And that hidden sophistication is exactly what wannabe copycats overlooked, leading to costly failures outside Nevada. The copycat trap. As the Nevada rumors spread and the whispers of success grew louder, it was only a matter of time before others tried to copy the idea. If dumping bees into salty soil really worked, why couldn't farmers in California, Utah, or Colorado do the same? From the outside, it seemed simple. Spread some salt, release the bees, and wait for fields to overflow with seeds. But the imitators quickly learned a hard lesson: not all dirt is equal. The first wave of failures came from California, where eager growers prepared their own bee beds to mirror Nevada's supposed experiment. They purchased bees, salted their fields, and waited. But California's soil chemistry, shaped by different mineral histories and rainfall patterns, wasn't a match. Instead of thriving, the bees refused to nest, scattering in search of better ground. Some simply perished. Without Nevada's specific blend of salt and alkalinity, the experiment fizzled before it began. In Utah, the problem wasn't the soil, it was the water. Farmers assumed surface irrigation would be enough to keep bee tunnels stable. But those who truly understood Nevada's conditions knew better. Beneath the crust, subtle moisture balances mattered. Too dry, and tunnels collapsed. Too wet, and broods drowned. Nevada's rumored success would have required underground irrigation networks, hidden from cameras, but essential for survival. Utah's copycats hadn't factored that in. Within weeks, their colonies were gone. Colorado's attempts were even more dramatic. High altitude and cooler nights created conditions far removed from Nevada's desert basin. The bees, adapted to one specific rhythm of heat and daylight, simply couldn't adjust. What looked like an easy transfer of methods turned into a costly disaster, leaving farmers with dead bees and empty fields. The pattern was clear. What outsiders saw in viral clips, a salty crust, buzzing swarms, and skeptical laughter, wasn't the full picture. They copied the spectacle, not the science. They missed the invisible details, the mineral balance that repelled parasites, the moisture control hidden underground, the genetic match between pollinator and crop forged over centuries. Without those pieces, the bee dump was just a stunt. With them, it was a system that could turn failure into abundance. And that's the lasting lesson. The Nevada rumor, whether exaggerated or not, points to a real truth about agriculture and ecology. Native pollinators matter. When matched with the environments that shape them, they can outperform imported bees, boost yields, and rewrite the economics of farming. They aren't a one-size-fits-all solution, and they can't simply be transplanted anywhere. But where they belong, they can change everything. For critics who mocked Nevada, the story became a reminder that innovation often looks absurd at first glance. For farmers, it underscored the importance of understanding ecosystems deeply before chasing quick fixes. And for scientists, it highlighted the potential of working with nature instead of against it. The internet laughed at the image of bees scattered across the desert. But beneath that image was a hidden sophistication that few appreciated at the time. So while the internet laughed at the idea of bees in the desert, the deeper truth is this: sometimes the strangest sounding fixes are the ones nature designed all along. If you enjoyed this look at Nevada's most mocked experiment turned mystery, make sure to like, comment, and subscribe. What do you think? Could using native pollinators be the future of farming in harsh places? Share your thoughts below, and check out the next video for more stories where science hides behind rumors.